Imagine for a second that everything you touch today, the plastic in your phone, the fuel in your car, even the clothes you're wearing, actually started as a thick, black, prehistoric soup buried miles beneath your feet. Most people look at a gas pump and see a boring errand, but you're about to see something entirely different. We're going to step inside the massive, deafening, and hyper-complex world of an oil refinery. This isn't just a factory. It's a modern-day alchemist lair where fire, pressure, and chemistry turn literal sludge into the lifeblood of our entire civilization. Imagine for a second that everything you touch today, steel, and steam surprised even the engineers who designed them. Even the clothes is a place of controlled chaos. Actually started thousands of sensors fight against the prehistoric suit buried miles beneath happening right under our noses. Most people look at a gas pump. You might think you know how oil works, but you're about to see something that nobody tells you. We are going to step inside the massive, deafening, it's about breaking reality apart at the molecular level. Oil refinery. Are you ready to see how just a factory is truly built? It's a modern-day alchemist lair where fire, pressure, and chemistry turn literal sludge into the lifeblood of our entire civilization. Imagine for a second that everything you touch today, often thousands of miles away from your refinery, the fuel in your car, even the Saudi Arabian deserts, actually started under Siberia, prehistoric soft buried miles in the Gulf of Mexico. Most people look at gas pump, dark, viscous, and honestly quite stinky. You're about to see something entirely different. Reservoirs. We are going to step inside the massive. We are talking about massive, complex networks here. Oil super tankers the size of skyscrapers hauling millions of barrels. It's a modern-day alchemist lair where moving at slow pressure, relentless pace turn literal sludge into the lifeblood of our entire civilization. When this crude arrives at a refinery, it's not just a uniform liquid. It's a chaotic cocktail of hydrocarbons, sulfur, and trace metals. It hits the refinery at a purity level that is essentially zero. It's dirty, it's raw, and it's completely unusable in its current state. The cost of refining a single barrel varies, but the process of turning that sludge into high-grade jet fuel or gasoline is a high-stakes game of thermal economics. The sheer scale of the storage tanks you see at the docks is mind-bending. Each one can hold over 500,000 barrels, and they are essentially the world's most dangerous, most important batteries. But the journey from the Earth to the refinery is only the beginning of the mystery. The real madness happens once that crude enters the pipeline, where it meets temperatures that would vaporize a human being in seconds. If you think the transportation is impressive, just wait until you see what we do to these molecules once we trap them in a furnace. The heartbeat of every refinery is the atmospheric distillation unit, a tower that looks like a giant vertical skyscraper made of steel. The crude is heated to roughly 370 degrees Celsius, or about 700 degrees Fahrenheit, until it becomes a turbulent, superheated gas. This vapor enters the base of the tower, and this is where the magic, or the science, happens. As the vapor rises, it cools, and different components condense at different heights based on their boiling points. At the top, we collect the lightest gases like butane and propane, while the heavier stuff, the thick asphalt and heavy fuel oils, stays at the bottom, near boiling and viscous. It's a continuous, 24/7 process that runs at high pressure, often exceeding 200 psi to keep the liquids flowing like water. The smell here is intense, a sharp, metallic, chemical tang that hits the back of your throat. You can feel the vibration through your boots. It's a deep, rhythmic hum of thousands of tons of metal and millions of gallons of liquid in constant motion. But this is enough. We need more gasoline. So we use a process called cracking. We take those heavy, useless molecules, heat them up even further, and use a catalyst to literally shatter them into smaller, more valuable chains. It's like breaking rocks with a hammer. But the hammer is a chemical reaction that happens in the blink of an eye. The pressure inside these cracking units can climb to over 300 psi. If a seal fails, the resulting pressure release isn't just a leak. It's a catastrophic event. And yet, this happens every single day, right beneath the feet of operators who keep the whole thing from tearing itself apart. The noise is the thing that truly haunts you. A constant, high-pitched whistle of gas rushing through narrow apertures and a heavy, mechanical thrum of pumps moving millions of gallons per hour. It's a sensory overload. But what happens when machines decide they've had enough of heat? In a modern refinery, the human eye is essentially useless. We rely on a digital nervous system of thousands of sensors, laser scanners, ultrasonic thickness gauges, and AI-driven vision systems that watch the pipes for microscopic cracks. These systems check for corrosion down to the micron. If a pipe wall thins by just a fraction of a millimeter, the AI flags it before a human even notices. It's a level of precision that defies logic when you consider the sheer, brutal size of machinery. Quality control here is life or death. Every batch of fuel is tested against international standards like the ASTM, ensuring that the sulfur content is virtually non-existent, often measured in mere parts per million. If a batch fails, it's not just thrown out. It's sent back to the start of the process to be re-refined. The rejection rate for finished products is effectively zero because, in this industry, the cost of an error is not just a lost dollar, it's a headline. There's one thing machines still cannot do better than humans: intuition. Despite the AI, the master operators, the guys who have been walking these catwalks for 30 years, can tell if something is wrong just by the sound of a pump or the specific color of a flame. They can feel the vibrations in their teeth when a pressure vessel is stressed. It's a primal human skill that keeps the technology honest. But even with that experience, we've reached a point where the machines are starting to predict failures before they even manifest. The efficiency levels are staggering, but even the best technology has a breaking point. What if the very process we use to create our energy is fundamentally changing faster than we can adapt? To understand the scale, you have to look at the numbers. Every single day, the world consumes nearly 100 million barrels of oil. That is not just a number. It's a constant, flowing river of energy that never sleeps. The global market value for the refining industry alone is measured in the trillions of dollars, supporting millions of jobs from the roughneck on the rig to the software engineer in the control room. The top 5 countries, the United States, China, India, Russia, and Saudi Arabia, control the vast majority of this output. Over the last 50 years, refineries have evolved from simple boiling pots into some of the most advanced chemical laboratories on the planet. Did you know that the modern refinery can process crude oil into over 6,000 different products, including the ingredients for medicine, plastics, and even high-performance asphalt for our roads? It's not just gas for your car. It's the physical fabric of the modern world. Here's a shocking fact. If all the refineries in the world stopped working today, the entire global economy would effectively collapse within 72 hours. Everything from food supply chains to electricity grids depends on the output of these machines. And the future? In the next 10 years, we're seeing a massive pivot toward green refining, using hydrogen and captured carbon to try and clean up the process. It's a race against time, innovation, and the finite nature of our resources. We started this journey with a dark, prehistoric liquid beneath the earth, and we followed it to the fire, the pressure, and the digital eyes of the world's most advanced factory. It is a cycle of transformation that few ever see, yet everyone relies on. It's the story of how humanity bent the laws of chemistry to turn the Earth's ancient past into our future. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the Earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.